All right, good afternoon, ladies and gentlemen. I would like to present to you a work that's done by three SAIS faculty members, Mike Gallant from the IT team and Shutiang Ma, who is a PhD student, but also Keith Schoening from Burning Glass Corporation, and then Ling Fei Wu and James Evans from the University of Chicago. And what we are interested to understand is the gap between what's happening in science technology, what job markets really need, and what we are offering in the middle in terms of courses. And so you have here a landscape. As you know, I like maps. Now, thanks to Lisa and others, we actually have a lot of the maps of science in our building hanging. Many of them are fabricated by faculty here in this school. But what you see here is for the first time a map that does not only show publications in terms of science technology advances, but also shows courses and also shows jobs. And the paper, which is currently under review, has a real map, but I can't show it to you, sorry for that. What you, however, can easily see is that if there is, for instance, a burst of activity in science technology, there should at some point also this topic be covered in the curriculums and in the courses we teach. And similarly, there might be job market developments and industry innovations that also over time should make it into the courses we teach. And as you know, we have currently a lot of committee meetings surrounding data science, surrounding intelligent systems engineering, and probably in every single other department also. And ultimately, we need to have a more data-driven understanding of what kind of topics we should teach, and we should try to minimize the delay from what's happening in the job market to what we actually teach, and also minimize the delay from what happens in the science technology area to what we teach. So it's coming from both sides. And as you know, some of these mountains are well aligned. In other cases, there's data science, which actually might change over time, where it sits in that landscape. So the topical composition might change over time. And again, there are major delays between those three areas. Ultimately, the results of this analysis are used by students because they need to understand what kind of job will be there in 5 years, what kind of courses should I take to be ready for them. Teachers need to understand what they should be updating and what is the balance of timely and timeless knowledge. I think that's especially interesting. Universities need to figure out, should I create data science? Should I create intelligent systems engineering? And what composition should it have? Science funders, employers, economic developers have other questions, but they can be partially answered by these kind of systematic analysis. And ultimately, every single one of us has to figure out how to spend their time, money, and compassion. And so what we did here is to take Burning Glass data, job postings between January 2010 and 2016, 132 million job advertisements. We also have access to the Web of Science data here, and right now we are using the Chicago data set, but very soon the iUni data enclave will have data up to December 2016. So we are going to rerun that all, hopefully in the time we have between review and it accepted, and we have to revise with the more fuller data set. And then we have about 1,000 courses, mostly in data science, data engineering, because that's the focus area we have. Now, the results I'm just going to hint at here because I'm going to run out of time very quickly. We basically did a crosswalk between those three different data sets based on skills. So you take 31,000 skills and you try to identify them in the Burning Glass job data, in the courses, and in the science technology publications. Maybe at some point you could also bring in patents. We didn't do this here. Then you look at the timing and the strengths of bursts of activity in those three landscapes. You can also do other analysis which then help you understand that actually uniquely human skills such as communication, negotiation, and complex service provisioning are currently under-examined in research and undersupplied through education for the labor market. So this is actually a major argument for having an arts and humanities campus like what we have here. And this is especially true in an economy which is driven by artificial intelligence and the fact that many of the jobs which people today have will be taken over by machines. It's also interesting to see that the same patterns exist for data science, data engineering, where teamwork and communication skills increase considerably in value over the years we are looking at here. And there's a greater and greater demand for data analytics skills also. And the skill demands ultimately from industry are also as likely to drive skill attention in research as the converse. So papers under review, if you would like to read it, we would love to have expert comments. We are also running user studies right now that help us understand if these maps we now have are legible for human beings. Thank you all.